somehow that plan is hold, and we will release a video and launch a video of that. I'm sure.
Sir, you have been muted. Yes, sir.
Hello. Okay. So with your presence and with your experience, I'm sure it is going to be a very learning experience with us. And I want to thank every participant here. At least now we have 125. So it's a record presence since last say 10-15 days. So Indrani, I think everyone want to hear Dr. Mukherjee, so I will not waste much time, and we'll go toward that how to secure our water availability, and how to be more civilized in terms of using water. And that is why watershed management is very much needed. And if we see that watershed management
Thank you, sir. Thank you, sir. Now I would request Professor Sanjeev Ghosh, who is the Professor of Eminence at the Adamas University. Sir, would you like to speak a few words on today's topic? Is Professor Ghosh present here?
I think I couldn't see sir. Maybe you
Okay.
couldn't join now. Maybe we will get sir later,
Okay.
and then
Yeah.
we can.
Okay.
Yes.
Okay. So I now request Dr. Indrani Ghosh, Assistant Professor Environmental Science at the Adamas University, to introduce speaker Dr. Abhijit Mukherjee to us. Yes, Dr. Indrani.
Thank you, Kranti. We are extremely overwhelmed to get Professor Mukherjee here today. And it's my great pleasure to take this opportunity to introduce our honorable speaker, Dr. Mukherjee, Dr. Abhijit Mukherjee, to the audience. Professor Abhijit Mukherjee is a PhD graduated from University of Kentucky, USA, and he completed his postdoctoral work at the University of Texas, Austin in the year of 2006 to 2008. He has previously done his master's from University of Calcutta and jointly with the University of Kentucky, and he had postgraduate diploma in computation engineering as well. He served as the physical hydrogeologist at the Alberta Geological Survey in Canada in the year 2008 to 2010, and currently he is associated with Department of Geology and Geophysics and School of Environmental Science and Engineering at the Institute of at IIT Kharagpur. He has published more than 100 journal papers, and he has served in editorial roles and is serving still in the Journal of Hydrogeology, Applied Geochemistry, Journal of Earth System and Sciences, and many more. Professor Mukherjee's main research areas include physical, chemical, and isotope hydrogeology, including numerical modeling, computation, contaminant transport, water policy applications. He is globally known for his studies on geological and human-sourced groundwater pollution, for example, arsenic, fluoride, sanitation-borne and emerging contaminants, and also in water quality estimates, including application of advanced computation and artificial intelligence techniques. For his work on groundwater, among several accolades, Professor Mukherjee has been conferred the National Geoscience Award in 2014 by the President of India. In 2016, Kharaka Award. In 2020, he was recognized as a fellow to Royal Society of Chemistry. And he has been named as the top 50 leading scientists and experts who are under age of 50, under the age of 50. And he has been awarded the most prestigious award in science in India, that is Shanti Swarup Bhatnagar Prize in 2020. So So without much delay, we are all waiting to hear from you, sir. So I request you to please take over. Thank you, sir. Thank you, Professor Mukherjee. Sir, I request you to take over. Sir, you're in mute. You need to unmute, sir. Thank you.
Yeah, it's working now.
Yes.
So thank you so much, Dr. Ghosh. So how much time are we looking at?
Sir, 1 hour
45
is
minutes?
45 minutes, fine, fine, absolutely fine. You can even 1 hour is okay.
Okay. Thank you so much for that elaborate, introduction. I'm really honored to be here today and be the guest for the World Water Day, which was yesterday, and across the world, across the country, there were so many webinars and lecture series. I also had to present one of the conferences. So I think it worked out well, having the lecture today, because if it was yesterday, then it would have been kind of colliding with another invitation that I had to attend. So a very good morning to all the guests and all the faculty of Adamas University. So I'm supposing this is the Kolkata campus?
Yes, sir. It's in
Okay.
Kolkata. It's in
Where-
Barashat area.
Barashat,
Yes.
okay. Okay, so Kolkata is my hometown, so it's almost like coming back to home. So let me just, without further ado, let me just start on the presentation for today. Just give me a second. So is the screen visible now?
Yes, the screen sharing is started. Yes, it is visible.
Okay. Okay. It's coming in full mode, right?
Yes, sir.
Yes.
Okay, thank you so much. So I'll be talking about a topic which might be of interest to you, and I would not try to make it too technical because then I'll lose the audience. So talking about the groundwater for future India, and talking about how science and human practices and policy interventions all kind of have a role in guiding and preserving the the very important resource for livelihood for the future times of India, and what is the present status. So as I was introduced, I am Abhijit Mukherjee. I'm an associate professor at the Department of Geology and Geophysics. That's my mother department. But I'm also a joint faculty at the School of Environmental Science and Engineering, where I look after the research facility. And at IIT Kharagpur, I have two groups that I represent, which is my original group, which is hydrogeology at IIT Kharagpur, where I have about 15 PhD scholars as of now, and also like a cross-discipline group that I have kind of formed in the last few years, which is the Advanced Policy Advisory in Hydrosciences. Now, before I go for the presentation, I would definitely like to acknowledge my collaborators, because again, things I'll be talking about, not all of them have been achieved without the support of all these agencies. And these agencies includes a number of Government of India institutes, organizations, ministries, as well as several other institutes or organizations of international repute. So I have been working with many of them for almost last 22 years now. So I thought like I'll put this acknowledgement before I begin. So groundwater. Now at present I've been asked to at present I've been asked to lead a section of the UNESCO or United Nations World Water Report coming up in 2022. And there are numerous stalwarts who are working with me to get the things in shape. And it was very curious to see that like when we say groundwater, of course I have an impression because that's what I do. But then all these experts who are also from the water domain in some way or other, they all have a very different understanding of what groundwater is, and each of them have a very distinct definitions or thoughts and emotion about what groundwater is. So it was kind of a eye-opening for me. It, just even last night. so what I would like to say is that when we say about groundwater, all of you, or all of us, would have some kind of thought on what groundwater might be. So for a layman way, let me introduce groundwater as the water in the subsurface, the water that we need for our survival, and we need to secure it for our future purposes. Now, is it that only at present that we know about it? Well, I would disagree with that. And I would say that in India, at least, the concept of groundwater was there, even in the historic time periods. So I'm showing you this motif from the wall of the famous Jorbangla temple in Vishnupur, where it depicts the scene of Mahabharata on the 13th day of the war, where Arjun is piercing the ground to give out water to Bhishma Pitamaha, lying on the deathbed on the arrowhead. And what Arjun is doing is literally just piercing the ground to bring out the water, because otherwise pure water was not available in the battlefield. Now, if the scene of Mahabharata, which is at least give and take about 1000 BCE, so about 3000 years old, is a myth or a legend. Now, some people call them a history. I don't want to get into that. But even if whatever it is, it's a literary work that happened at least 3000 years old from today. There are ample examples of the presence and usage of groundwater in the Indian history. And that starts from Mohenjo-daro, the city of Wales. Mohenjo-daro, as you know, is a prime city in the Indus Valley civilization, and it has recorded more than 800 water wells, dug wells. All these dug wells drawing water from the subsurface or the underground. So Mohenjo-daro is regarded as a city of wells. And as you know, like Mohenjo-daro is at least like around 4,000 years old. And since Mohenjo-daro and across the history of India, there has been so many examples where groundwater has been used. Now, if we fast forward to modern India, we see that groundwater is used in every aspect of our life. That starts with the drinking water. It starts with the water that is required for our domestic purposes, the industrial water, water for urbanization and construction, and most importantly for food production. Now, it's a very misunderstanding to think that when you talk about water or groundwater, it is only for our drinking purpose that we are talking about. As I'll show you, that when we look at the consumption volume of water, and specifically groundwater, it is actually 85% or more that goes, sorry, I'm getting a bad throat. It goes for food production. And it's only about 6% that is used for domestic usage, including drinking water. Or in other words, it is actually food production that eats up most of the water. So if you want to look at it, both our food and drinking water security is pegged to the availability of groundwater. Now, that's easy for me to say, but how or what are the water issues in India? Well, as we know, like the summer is coming and the water scarcity is looming across the country. Earlier times, it was only in the places which are known to be traditionally dry. But as you know from the news reports and the media channels, in present times, this kind of water scarcity pictures are showing up even in the most water affluent parts of the country, including West Bengal. So water scarcity is not a myth anymore, it's a reality. But as water scarcity is happening, and again, water scarcity is mostly groundwater scarcity, as the water scarcity is happening, in many other parts of the country, you have water excess. And this water excess is caused by flooding. Now, again, this is a misunderstanding that flood is mostly an impact of hydroclimatic events. Actually, flood happens mostly for what we call a rejected recharge for groundwater. Or in other words, groundwater has a huge role to control the floods or impact the floods. Now, the interesting thing is this water scarcity and water excess kind of happens almost hand in hand at the same time, just few hundred kilometers away, which tells us that this must be not something just about the resource, but also about managing the resource. Now, whether you have water excess or water scarcity, we are definitely looking at drinking water security because either of them would impinge on your availability of drinking water. So the first thing we, as a human race or as an animal in this planet, we need to do is secure our drinking water sources, even before food. And so at present times, we are pretty much running short of that. And then, even if you have sufficient water, it's not good enough. The water has to be of good quality too. And what you see here, um, just a second. Okay. When I look at this water quality issues, it is just not having the volume of water that we are talking about, but also the chemistry of the water. If you are drinking polluted water, it is not going to keep you alive. So just having sufficient water is not good. And these photographs that I'm showing you, they are not taken from the Google or any third-party sites. These are photographs that I have taken myself, working in the field on areas which are known to be arsenic polluted. You are in the Barasat campus at Adamas University, and Barasat, at least parts of Barasat, is well known for its arsenic pollution. There has been several studies on arsenic pollution in Barasat.
Yes, sir.
So you know like what I'm talking about. So just drinking bad water, not doing anything else, no cards from previous life or anything like that, you can literally end up having this sort of, you know, life-threatening diseases. And lastly, but not the least, what happened? Was it freezing? Oh, sorry. And lastly, but not the least, we have the climate change. Now, I don't call myself a climate change expert, so I would refrain from calling or talking too much on that. But I definitely like to think it as a white elephant in the room. Or in other words, I doubt how many of us really understand what climate change is. All of us are talking about something, but then there is something else too. But one thing that we all kind of agree on, that if there is a climate change happening, the climate change is going to impact the hydrological cycle to be the first victim. Or in other words, all these things, the scarcity, the excess, the security, and the pollution issues that I just talked about, they all would be enhanced in future time given a sense that climate change is coming in and possibly have already started. So we are not looking at a rosier future, but possibly a more tougher future. And we have to be prepared for that. And this is more so because, sorry, this is just not India, but water scarcity is something that is across the world. It's just not India. And as some of you might be knowing about the United Nations Sustainable Development Goals, SDGs 2030, which says that by 2030, as a human race, irrespective of the country, caste, creed, religion, or the geography, we should be able to converge into 17 sustainable goals for the whole planet. Goal number 6 is access to clean water and sanitation. And many of the other goals are also, strongly linked with this goal number 6. So many of the things that we do, knowingly or unknowingly, are actually, serving the sustainable development goals in some way or other. So it is not, I'm just talking about the groundwater resource of India, but also as a world, by 2030, we have to find a uniform solution for the whole world. In the last about 15 years, well, 12 years to be more precise, there has been actually a lot of hue and cry on the groundwater scenario of India. And this actually started from two papers that got published in 2009. One by Matt Rodell, my dear, very good colleague and collaborator, Matt Rodell from NASA, as well as Professor Tiwari from the present director of NGRI. And they published two papers based on a technology that I'll be talking about today, where they showed that there is drastic decrease in the groundwater resource across India. So in the last about 10 years that I've started working in IIT Kharagpur after my returning from North America, my students and I have been working diligently trying to understand how much safe groundwater is available in the Indian subcontinent and what is the future. And in that, I would definitely like to stress the word safe, because it's just not the volume of groundwater, but also the volume of safe groundwater that should be required for drinking water purposes. So we need to understand that why even we study Indian groundwater, like, there are plenty of other things to study, very fancy things, I would say. But why do we need to study? Why is it an emergency? Well, if you look at the two maps on the top and down below, it's a map of the global population and the global crop production. You see in both the maps, India is on the hotspot in both the maps. So it has one of the highest population, it has one of the highest crop production. So if we come to the statistics, the Indian subcontinent hosts about 3% of the global terrestrial area. Indian subcontinent, that means India and its 7 neighboring countries, sisters. 3% of the global terrestrial area, that's as much as India hosts, whereas it hosts almost 1/4 of the global population and almost 1/3 of the global irrigated land. So by any means, and you are all very smart people, you know that we are looking at a stress. We cannot host 1/4 of the global population and almost 1/3 of irrigated land in 3% of the global land in Indian subcontinent. So at present, India and of course its neighboring countries, they're the largest consumer of groundwater in the planet. I'm showing you statistics from my good friend Richard Taylor, who published a paper in Nature Geoscience in 2014, where he showed, and again, there are a lot of other authors too, but this paper showed a very unique number that I think all of us, or many of us, were aware of, but we didn't say that since 1960s, when groundwater really got started to be used, India has been the world leader in groundwater usage. So much so that it is actually consuming groundwater at even a much higher proportion when if you take the second and the third one, which is US and China taken together. Okay, so US and China taken together, as much water they use, India uses more groundwater than that. So definitely we are the world leader, and there is no way that we're going to come down in future times, near future times. And within that, if we're talking about India as the largest consumer, within that, you look at this map with this kind of red areas on the top, and this map represents the Indus, Ganges, Brahmaputra basin, the 3 Himalayan mega rivers. Indus, the 4th largest river in the world. Ganga, the 6th largest river in the world. Sorry, Indus, the 3rd largest river. Ganga, the 6th largest river, and Brahmaputra, the 4th largest river in the world. So 3 of the largest river systems in the world coming out almost from the same place, which is the Himalayas, or a part of the Himalaya, and flowing down to the Indian subcontinent, producing a system, a geological unit known as the Indus, Ganges, Brahmaputra, and also Meghna for Bangladesh, Indus, Ganges, Brahmaputra, Meghna basin, and also known to be one of the largest host of groundwater resource of this planet. So the Indus, Ganges, Brahmaputra, Meghna basin is one of the richest and largest repository of groundwater in this planet. So there is no wonder that you have the highest irrigation or highest usage of groundwater in these places, in the Indus, Ganges, Brahmaputra basin, not in the whole of India. So if you go by a density perspective, this is possibly the place where you have most intense groundwater abstraction happening across the world. So I would like to make this bold statement that at present day, India is the largest consumer of groundwater, not only today, but in human history. So we are at the crossroad of making history of our lifetime. We are using the largest volume of groundwater that has been ever used in the human history of this planet. So we need to understand what groundwater is and where are we finding them. So one of the first thing we need to understand is the geology. The geology which defines the aquifers. Aquifers, you can think it as a bottle, which is hosting the water. So it is the geologic unit that would be hosting the groundwater if it is there. And if you go by this map on the left, you would see that there are several aquifer units. And of this, there is this bright blue aquifer units called the IGB, or Indus Ganges Brahmaputra Basin, which is covering from the Indus Basin in Pakistan to Bangladesh, Brahmaputra and Meghna Basin in Bangladesh, and combined Ganga in Bangladesh. So these IGBM basin is, as I said, is one of the best. Still today, it's one of the best. And then you have a lot of other types of aquifers. But these IGBM, according to statistics, host about 70% of the groundwater reserve of this planet. Sorry, of the country. So it is the largest, even from a country perspective, it is the largest repository of groundwater. And accordingly, the densest population of this planet also lives in these areas, mostly in the Bengal Basin, which is Bangladesh and West Bengal, parts of West Bengal. So the densest population of this planet. Now, when we talk about that, these areas in the Indus Ganges Brahmaputra Basin are having some of the highest volume of groundwater, it is also these areas, as you see in the map on the right, which are also polluted by geogenic pollutants or natural pollutants. This includes arsenic, this includes the fluoride, this includes the salinity. So the areas which are also having a lot of groundwater are also having a lot of geogenic pollutants. So if you think that way, the net water volume that is available for human consumption or human use actually is not that high. So you are actually intensifying or magnifying the space now if you add up the quality to it. And we want to keep this in perspective. Now, when we try to understand groundwater systems, and again, this is a bit technical, but I just keep it on a very superficial level. When the groundwater happens, it happens to what we call groundwater recharge, and that recharge water would flow in the subsurface, going through causing the aquifer matrix groundwater interactions. This is what we call the water rock interactions, which gives out the chemistry of the water, what you call actually, in reality, the mineral water. And then you have the groundwater discharge, which happens either in the rivers or in the oceans, eventually all in the ocean. And then you do have the climate change and human practices and policy interventions. So all of this eventually makes up the groundwater volume and the chemistry and the quality that you are looking at. So here, I'm showing you about for the last 2 decades, the groundwater recharge condition across India. And what you see is that the recharge pattern has actually changed over the period of time. It is not uniform every year, which suggests that as much as there are heterogeneities and there are differences on the ground levels, there are also climatic things that would influence the recharge volume. Now, when we are talking about the groundwater chemistry, we also need to understand, the mineralogical or even further smaller, like the molecular level interactions between the water and the rocks or the sediments. And this interaction with the water, with the rocks and sediments, gives you actually the largest laboratory, chemical laboratory in this planet. Why do I say that? Well, being a university, you have all these labs, right? Chemical labs, wet labs. And in these labs, you would run reactions, to show you students or even for your research. And, people would do acid-base reaction, redox reactions, and blah, blah, blah. But we as a geologist know that nature is the largest lab. And one of the truest form of that lab is in the subsurface when the water, the universal solvent, passes through the sediments or rocks. These rocks or sediments and the water actually goes through all the reactions that we have ever learned, from radioactive decay to second order, third order reactions. And acid base reaction, redox reactions, ionic exchanges, and everything. So these actually results to what we call the hydrogeochemical evolution, and, or in other words, develop the chemistry of the groundwater. And sometimes these are augmented by human practices, which would actually pollute, help, or increase the pollution extent in this water. So, for example, like at least in the case of Bengal, because of the high rates of irrigation pumping happens in Bengal, much parts of West Bengal, including Barasat actually, has been polluted by arsenic, not only from the geogenic sources. I mean, we know that arsenic is natural, but much of the arsenic is possibly being sprayed out because of pumping under conducive conditions. So here I'm showing you the first integration of the Ganges Delta. It's a paper published by my research scholar just few months back. And the first AI-based prediction of the arsenic content in the Ganges Delta in the transboundary India and Bangladesh. So sorry. So what we're looking at, I don't know, the cursor is not working properly. So this is about Barasat. Okay. So I'm just showing you Barasat. I hope like you can see the cursor. Is that my cursor visible? Is my
Yes,
cursor
sir.
visible?
Yes,
Okay.
sir. Yes.
Yes,
So
sir.
this is about Barasat. Okay. So you are pretty much in the arsenic hazard zone, and you are also looking at the population that might be exposed. And as you can see, Barasat has one of the highest population density per square kilometer. So taken together, more than 30 million people are under threat in just the Ganges Delta. And just looking at it geologically, I can see a lot of patterns, but that's another thing. But what it's trying to say that these water rock interaction and the pumping that I just talked about can cause a huge amount of nuisance for the human valley. Now, if that was natural, partially augmented by human usage, you also have absolute human influenced pollutions. And here I'm showing you a paper that we published again in 2020 that some of you might have seen, where we for the first time we tracked the highest or the most widespread distribution of organic pollutants in the Ganga basin. And this includes the Bhagirathi Hooghly River, that includes the groundwater as well as the soil in the Ganga basin, mostly in West Bengal. And we found that because of toxins, organic toxins, millions of people in Bengal are exposed to pesticide-laden river water and groundwater. So we human also have a huge role to play in moderating our groundwater. And last but not the least, possibly the most important one, is the sanitation-borne pollution. I'm showing you another paper or work that we have published quite recently, which is on the efficacy of um, um, sanitation or proper sanitation in groundwater pollution. Um, in sanitation-borne pollution in India. And what you're looking at is a map of 7,010 blocks based on data that we collected from about 17 lakh data point from the government of India, which shows over the years how groundwater quality has changed because of sanitary development or sanitation development, including the Swachh Bharat Abhiyan. As of present, government statistics says it's not COVID. More than a billion babies, infants, less than 5 years of age, dies every year just because of acute diarrhea, drinking bad water. You don't have to have COVID for that. Even today, a million babies dies every year in this country. So, yes, missions like Swachh Bharat Abhiyan and other things are helping, but we are not there yet. There is a long way to go. It may be just showing up the initial results. One more thing that we don't understand quite well is what is the interaction of river water and groundwater. And as I'll show you, that the rivers, okay, we think like, okay, there is a Ganga river and the Ganga basin, which is hosting the groundwater. But here I show you from this figure that actually Ganga river, which we think to be more of a glacial fed river, actually is a groundwater fed river. And that's true for most of the perennial rivers of this planet. Groundwater, in the non-monsoon periods or non-wet periods, groundwater provides the maximum volume of water to any of the perennial rivers, including the Ganga. And this volume can go up to 80% close to Kolkata. So with that kind of introduction, like a broad introduction, I would now try to focus on a very specific study that we have been involved in about the last 8-9 years, working with the NASA hydrology team on a mission called GRACE, Gravity Recovery and Climate Experiment. It's a mission that was sent out in 2002 by NASA, jointly with the University of Texas at Austin and the European Space Agency. My involvement with this project was since 2006, since my then postdoctoral supervisor, Dr. Abhijit Scanlon, one of the legendary hydro geoscientists of this planet, is also one of the lead scientists of this mission. But then I was not working. I started only working with the mission when I actually came back to India and through my students. So this work that I'm showing you is about two satellites, Tom and Jerry. The two satellites, which are positioned at a distance of 220 kilometers in the polar orbital and at an elevation of 500 kilometers from the Earth's surface. They go over the Earth's surface, over each point on the Earth's surface, 15 times a day. They were sent out in 2002 with an expectation that they would die out in 2007. They didn't, and they lived actually much more than the expected lifespan. And in 2018, only that the next generation satellites, GRACE A4, was sent out. And these mission in the last 15 years or so has actually revolutionized the water industry, specifically the groundwater industry and the climate change industry. These results have been phenomenal in understanding the Antarctic ice sheets and all these things. But specifically on the groundwater front, it has done a miracle. So our whole conception of the groundwater extent across the planet has changed because of the data arrived from the GRACE mission. So the way it works is as the satellite moves on the Earth's surface a few times over a day, it collects the gravity of that point, gravity. Now, when you think about gravity, gravity is mass into distance, right? Distance squared. Now, if the distance is fixed, it's 500 kilometers above the Earth's surface, and if the gravity is changing, that change has to be linked with the mass, change in mass. And we know from geoscience that a mass of a place would change in a shorter period of time only if there is a hydrologic mass exchange. Or in other words, unless there is a catastrophe, in a short period of time, the largest mass exchange that happens on the planet Earth is because of hydrologic mass exchange or hydrological transfer from one sphere to another sphere, from the Earth sphere to the atmosphere, and so on. So the GRACE data actually provides you the gravity data, because the technique is called space-based gravimetry or airborne gravimetry, and it gives you gravity data which can be translated to something called terrestrial water storage, the change in terrestrial water storage. Now, when we have this terrestrial water storage, that includes all water on Earth's surface. So what we have to do is we have to subtract the changes in soil moisture, snow cover, and surface runoff that we can calculate out from supercomputer models that are running continuously in some of the best lab in this planet. And when you deduct these volumes from the terrestrial water storage, you literally get what is the change in groundwater storage of each point on the Earth's surface. Now, as I said, like the first set of data from the GRACE missions came out in 2005, 2006. And since then, it has done miracle. But in India, excluding that one or two papers long time back, and that also, very local scale papers, nobody actually were capable of, validating the groundwater storage component of the GRACE mission in India. So when I started the work in 2010, 2011, because I knew this NASA group from my PhD days. So we contacted them and we said like, okay, now that I'm back in India, I'm in a position to work with you guys and, validate this. I know the working, so I think we are in sync. So what we did is we formed a collaboration with the government of India, Ministry of Water Resources, the Central Groundwater Board, and with the collaboration between CGWB, IIT Kharagpur, and NASA, we demonstrated that the space-based data or the satellite-based data that NASA is giving and the groundwater level, pinpoint level that the Central Groundwater Board is releasing in terms of data, they are reasonably matching, of course, after a lot of manipulations, mathematical manipulations. Mostly they are matching in most of the regions across India. So this is kind of the bi-decadal or 20 years of water level fluctuation trends across each of the points in India. And what you're seeing are the various colors, which depicts whether the groundwater storage or level is increasing at each of the points or they are decreasing. So this is kind of the decadal groundwater storage condition in the planet, and I'm sorry, over India, and from 2003 to 2014, and now we have also updated data to 2018. So what is you should be looking at are the colors. The color changes. Blue is good, red is bad. Blue means you have more water, red means you have less water, groundwater. So look at the patterns, and I'm sure like you can distinguish that the color is changing. The color is changing so much that the blue areas in the Indus-Ganges Brahmaputra basin has overtly turned red in about 10 years of time, 11 years of time. Whereas areas in southern India and western India, which were red to begin with, are now blue, which tells us that across India, the groundwater storage has been changing in different levels, and we need to investigate or understand it. So this is a figure showing the 5 blocks of India: north, south, east, west, and central. And if you take India as a one block, and how does the groundwater storage change linearly? It shows that in northern India and eastern India, groundwater storage is depleting, going down, with a higher gradient in eastern India, which is eastern Bihar, West Bengal. Whereas in southern India, central India, and western India, the storage actually is increasing a little bit, very little, but it's increasing. So if you overall take all over India, groundwater storage is depleting, but not as high the rate is that you would expect in eastern India or northern India. So when we clear out all these various colors that I showed you, you end up with these two maps. The two maps, the blue one showing groundwater storage increase or accumulation, and the red one showing groundwater storage decrease or depletion. But in other words, the red areas are where we are having groundwater drought, and the blue areas are there where you have groundwater replenishment. So let's understand groundwater drought. Now this is possibly easier to envisage, because that's what we have seen over the summer times, mostly in the recent times. You see all these very scary pictures that people lining up for kilometers to get some water. But what caused it? Well, as we know, introduction of high-yielding crops for paddy and food cultivation that started back in the 1970s with the Green Revolution. And for these water-intense crops, you need to have extensive flood irrigation. And this flood irrigation needs a huge volume of groundwater to be taken out from the subsurface. Many areas, mostly in the Uttar Pradesh, Haryana area, many of the traditional crops are actually exchanged or converted to water intense cash crops. These are not native crops, so they don't have a balance or equilibrium with the groundwater condition of the area, and they actually have or intake more groundwater than the traditional crop would take. Thus, kind of departing from the equilibrium system. All of this needs severe groundwater exploitation. Now, some of my colleagues talk about climate change. Now, to begin with, I said I'm not a climate change expert, so I'm not going to comment on it. But saying that, even then, I doubt that whether climate change would be causing what we are looking at, because my understanding is that climate change has to be looked at a time scale of at least 30 years. And what I'm showing you is only about 10 to 15 years. So I don't know whether you can really pick up climate change imprints from images like this. Now, a more subtle observation, which is you would not be knowing otherwise, is, as I said, that for big rivers like the Ganga, there is a huge volume of water that comes from groundwater. And it's a matter of fact, and this is from one of our recent studies, which shows that this groundwater abstraction from different parts of India, specifically the Indus Ganges Brahmaputra basin, actually is drying out also the rivers. So a matter of fact is that Ganga is drying. And if it dies by 2050, we are going to have 100 million people in the Ganga basin starving from not having food. Forget water, not even food. 100 million people in the Ganga basin. And then the pumping would have an essence of influencing the arsenic transport. The arsenic transport, which originally we thought is a conservative event, but after a lot of studies, we have showed that the arsenic transport is reactive, and because of pumping, the flow gradient can get magnified by 20 to 40 times of the natural gradient. So something that would take about 250 years to reach a point can now reach within 5 years of the starting of the pumping, thus polluting more area than it can. But these are things possibly we know of. What we don't know of is groundwater replenishment, or
Sir, is there any network issues from your side? Dr. Mukherjee? I think there might be some technical glitches. So I request all the participants to just be patient. Perhaps it will be sorted out pretty soon.
Let me check, sure.
Yes, you were saying that by 2050 the
Yes, India will be.
India, there will be
will-
around few million people who will be facing.
So we talked
This-
about this slide, right?
Yes, this one.
Okay.
This was done, sir.
Okay, okay, okay. Yeah, I don't know like when I got disconnected. Anyway, what I also want to talk about is, while that was something, of course, which many people would not be knowing, much more, um, much more obvious impact of the pumping of the abstraction is actually also, just spreading out the groundwater arsenic. And our study shows that the groundwater arsenic, which would, naturally travel to a place, one point to the other point in about 250 years, in presence of pumping, that can happen in 5 years. So the transportation of the arsenic can be increased or magnified 20 to 40 times just because of the pumping that is happening. So more areas in the Ganga basin or Bengal basin are getting polluted because the pumping is happening. So while the Green Revolution, which started in the 1970s, that made us or made our country a food deficient to food sufficient to food exporter country, it came with a cost, the cost of groundwater, which is of course something we don't want to be that way. But on an optimistic note, we also saw that parts of the country is going through something called groundwater replenishment. Now, of course, this is something you would otherwise not be, very much hearing about. Most people talk about groundwater getting out and drying out and everything. So when we first observed it through our data, we were also not very sure like what are we observing, because these are satellite data, right? So we wanted to make sure with the ground data. So I'm showing you the bidecadal groundwater level trends across the country, and we found out that in Gujarat and Andhra Pradesh, Australia and Andhra Pradesh, there are these very obvious water level increase in the wells, and these signatures are quite matching with what we see in Gujarat and Andhra Pradesh in the satellite data. So our satellite data and our groundwater level data are actually in sync. So we are pretty much looking at the same thing. So we are confident now that the groundwater rejuvenation is happening. I hope I'm still online. Under his leadership, Gujarat government understood that they have to conserve their groundwater. And what happens is that to conserve this groundwater, they, typically in many of these Western states, they give out free electricity or very cheap electricity for running the pumps. And that was also the case in Gujarat. But what the Modi government in 2002, 2003 did is they started splitting out the electric or electricity feeder um, from the households to the agricultural fields. So while the households will still have 24 hours connection, the agricultural fields feeder would only have 8 hours connection now. Or in other words, it enforced a rationing of the electricity usage for pumping. The project was called the Jyotigram project, Jyotigram. And again, it was not, not actively, intended toward, groundwater replenishment, but more rather conservation of groundwater. But it seems it has worked. So if that was anecdotal observations, what we did is we simulated the groundwater condition of Gujarat from 1996 to present. And we saw that, yes, the groundwater condition was dipping from 1996 to 2002, about 2002, when we know that the policy intervention has happened. And the simulated water level in presence of um, um, policy interventions did slowly came up, matching quite well with the ground observation that we have from Gujarat. So Gujarat is one such state where the groundwater is actually getting replenished instead of getting depleted. And the whole credit actually goes to the people who have been able to manage and actually, kind of change the curve of the, uh, you know, reserving this natural resource. So overall, this is the state of affairs. While we are losing about 8.5 to about 5.5 cubic kilometers of groundwater across northern and eastern India every year, we are actually gaining about 3 cubic kilometers of groundwater in South Central and West India. Or in other words, in India, we have a net loss of about 10 cubic kilometers of groundwater every year as we are going through. Now, if this continues, this would really cause an havoc, and our whole country would just dry out in the next few decades. But then we also have this observation of a positive possibility, a silver line. So if we can use some science and knowledge and technology and try to integrate this for better management and better policy interventions, we still have a chance or a case to come back. So this study was quite popular, and it actually showed a lot of things which people might have been talking about, and many times they were not even talking about, and eventually became the NASA image of the day. Was in the NASA website for a day on the 22nd of September 2017. Just focusing our study, and the media certainly pick it up, and I'm happy to let you know that at present the lot of efforts that goes in the groundwater rejuvenation in terms of Jal Shakti mission and all these things, it actually in some way got influenced by our study, because it was our study and subsequent my presentation to the government of India officials at very high level, um, up to the Union Secretary level, where I demonstrated the scientific facts that are happening. And they really commended our observation and eventually decided to change the policy interventions in a way to conserve the groundwater in this country. So, at present, the Manrega, is Manrega, which is the largest social schemes that the government of India runs. 75% of the fund of Manrega is now kind of earmarked for groundwater rejuvenation um, methods or implementation. So it did do some very good positive outcome. However, on a side note, I would also like to say that when they are taking cognizance of the science and eventually implementing it, what is missing is once the science has done its part, the managers or policymakers, they are not consulting the scientists any further. Then, like people who are mostly in administration and other social science maybe even, they are now start taking the call. Consequently, the science which actually helped to find out, I would say the medicine, actually is out of the game. So my word of caution is that if you have to have the best outcome of this phenomena, you need to also integrate science to the best we can. So I would end this lecture with just a promo. I would say just a promo. Like, this is a book that just got published by Elsevier, which I edited, lead edited, along with some of the biggest names in the planet on groundwater. So if anybody is interested, please feel free to take a look at it. Many of the things I talked about are inscribed out there. Would be happy to take any questions that you might have. Thank you so much. Hello.
Yes, sir.
Yeah, I'm done. Thank you.
Okay. Thank you, sir, for the immensely informative lecture that you have presented. And I would, first of all, I would thank you for this eye-opening lecture, I think. Yes, there are some little bit of questions that some of our participants has been communicated to us.
Sure.
One of is Ms. Aparajita Bhattacharya, who has mentioned how far India has gone in terms of overcoming the arsenic contamination, and what is the kind of governmental and non-governmental effort that has been put in for mitigating such a menace.
See, arsenic is a natural pollution, at least the one that we see in India. It's 95% natural. there might be 5% coming from other sources. And we think like it's mostly coming from the Himalayas. So you cannot really do much about it in terms of the science. What you can do is the technology interventions, which is treatment of arsenic prone water. So you would see that in many, mostly specifically in West Bengal, there are many places where you have these arsenic treatment plants, and people are treating the groundwater as they bring it out. The government is treating it and then supplying it to the community. So there has been a lot of investment in terms of that, and we fairly well understand now that you cannot just get rid of it. It's there, and you have to live with it. Okay, so you have to treat it and supply it to the people. So technologically, science-wise, I think it's fine. The investment is fine, and of course, the government has invested a lot of money. At least in West Bengal, as I know. Problem is somewhere else. The problem is where you now have to maintain these arsenic plants, arsenic treatment plants. And from my experience working as an advisor to the government of West Bengal, I've seen in many places almost 60% of the plants would fail in operation after 3 years. And the cause is not the science, the cause is not scientific or technological know-how. It is more the human nature and just the attitude that we have as an Indian. So after a period of time, once the initial money is spent, we as common Indian, we don't take pride or effort in maintaining the plants. See, the government cannot do everything, right? The government can bring in the money, invest, construct it and everything. But if the pump operator who is down there is not running the pump or running the filter, what can the government do? They can do a overseeing project, but that cannot correct the problem. You can create some fear in the pump operator mind or the local vendor who's supplying the chemicals, but you cannot take out the menace, right? Okay. So it's a interesting question, and of course it's a fair question. So in terms of investment, I would say a lot of investment. In terms of knowing the scientific know-how quite well, problem lies somewhere else. Okay.
Yes, sir. The next question that would be, I would be focusing on mostly on the groundwater research. One of our participants, Mr. Nilesh Burman, he has pointed out that groundwater replenishment, the pace that we are trying to and we are making an effort to replenish the groundwater, is keeping pace with its depletion.
No, it's not.
No, definitely not.
Yeah, that's why we are losing, 10 cubic kilometers of groundwater as of 2017.
Exactly.
However, on a positive note, as I said, the government has taken cognizance of this. And again, see, like neither the administration or neither the community can do anything alone. It has to be, transition from the highest authority to the lowest people on the ground. Unless this transition is made or the chain is connected, you would not get the best effort.
Exactly. And also connected to that question, another observation is like the way the deserts are being approaching towards from the western end, western frontier, that the desertification is coming into our mainland, and I do not say mainland, are encroaching most of our lands on the western end. And with the development of Gujarat that you have pointed out, how much, what do you think, how much this development can benefit ourselves?
See, it's, well, I don't know about the approaching of the desert. Actually, it's in the contrary. Among one of the states which also get benefited from groundwater rejuvenation, it's actually Rajasthan.
Okay.
So instead of the desert approaching, actually much part of eastern Rajasthan is actually become greener. If you go to Jaipur, and I have worked in Jaipur myself for years, actually much of the desert is now reclaimed as cropland.
Well,
so yeah, so
then that's a silver lining.
Yeah, that's a silver lining, and that desert is actually not actually coming to the mainland. What is happening is rather the contrary of that many of these so-called croplands or mainlands, which are more let's say Punjab, Haryana, and now in Eastern India, because of people not being very aware of things, or rather, I would say, I'll go one stage ahead and say greedy. The greed of the people actually has been ruining the the whole scenario. And again, it's very easy to say greedy, but then see, like all of us at all levels or at our own personal level, we try to make the best use of the resource that we have, right?
Yeah.
And many times when we try to generate that, we forget, or maybe we are not just knowing that how much um, detrimental it can be in a larger scale.
Exactly.
And this is actually what's happening. And um, so many of the times, and this question I face in many places, that uh, what is your take on the irrigation practices and why is it drinking out so much water and so on. The problem is there are a couple of, I mean, I'm not a social scientist, but what I see that irrigation practices in India, in most of the country, actually has not much developed in the Indus Valley civilization days. So it has not actually changed much from the last 5,000 years, right? So cultivation is being done the same way it was done by our forefathers in the Indus Valley. Science has moved a long way, since, and we have not still yet been able to take the best out of it. Because we talked about the flood irrigation. Now, we never evaluated whether we actually need the flood evaluation for crop cultivation or rice cultivation. And if you look at a more scientific way of doing things, actually you don't need that. That flood irrigation, we do that because our forefathers did. If they got good results, I'm sure we will also get good results. So we just take out the water because it's free, the electricity is cheap, and we can afford it, not thinking about the greater consequences that it might have.
And linked to the same thing, another question. How do you feel that such dams, making some big dams like Tehri dams in the upper Himalayan flow of the Ganges, can do a benefit in terms of groundwater recharge? Because actually we have pointed out to some extent to such
See,
efforts.
in the Himalayan region, again, like working in the Himalayan region is a different beast, because the techniques I described about, they would not hold good in a system like the Himalayas, where you have a lot of change in topography. However, from my own field work and everything, I know that in the Himalayan system there is a lot of groundwater. These dams are actually doing, I would not say all the dams, that would be a very generic statement, but many of these dams are actually causing the opposite of benefit, which is damage. Now, how is that? Well, a lot of people talk about, unplanned growth of dams and all this thing. And we know about the catastrophe that we had in Himachal Pradesh, Uttarakhand, just few weeks back. And most people talk about the construction and all these things. What none of them talk about is what is happening in the subsurface, because that's not their domain. I understand that. What actually happens is when you construct these dams would change the equilibrium between the groundwater and surface water interaction in a very short period of time. So the nature doesn't get its time to re-equilibrate with the present condition. Or in a sense, the groundwater dynamics or the flow dynamics in the subsurface changes. Consequently, what it happens, it builds up extra fluid pressure in the whole system. And this fluid pressure is counter to the strength of the material. So earlier the rocks, the way the mountains were holding out together. Now this increased fluid pressure because of the dams or the consequences of the dams actually is working against the cohesion, causing the whole system to fail. So if you had a chance to travel to the Himalayas, I have done quite often, you would see that as you come closer to the dams, like 5 kilometers, 10 kilometers just ahead of the dams, you would see that the whole area kind of looks very unsettled, if that's the word, what I would like to say, because this whole area now has rockfall, broken roads everywhere. Although other areas of BRO have very beautiful roads. This tells us that uh, that the dams have a huge role to play. So I would not say the dams would be causing a lot of benefit. They possibly does in many places, but not in the Himalayas.
Well, sir, another question from Shomi Bhattacharya. She pointed out that how to make people aware of groundwater security and water conservation, especially to those who are not in touch with education in areas like UP,
Right.
Haryana.
Right. So that's a very important point that you made up, education. And I personally feel like education, and specifically girl education or women education, is a huge. I mean, that's a huge thing that needs to be done. And we have found over and over again places which are more educated, and specifically girl education quality is higher. Many of these menaces, including water pollution and including groundwater rejuvenation, has actually gone better. So of course, education has a huge role to play. Now, again, I'm not a social scientist, so I really cannot really put a lot of comment into that. But since I work closely with some social scientists, I can see that communication and mass communication in a lot of way can actually make a lot of change. You know, many of us possibly, I don't know, like back in the 80s, early 90s, when AIDS, the disease AIDS, was spreading out across the country quite rampantly. Actually, people talk about a lot of intervention. Again, I was a kid that time, but I still recall the TV ads, the Buladi ad, right? And I think it did miracles. And people, in a very short period of time, a very wider section of the population was very effectively, communicated about, you know, how, it can cause even the pandemic. All the media hype and all this thing has actually, in some way restricted the spread of the COVID in some sense. So in water also we need to do that. The problem is somewhere else. Like while you are doing that, which is all good, in some way it's cosmetic, and that's also important. Cosmetic is also important. You should not neglect the science, and that's what my first-hand experience tells me. That when it comes to cosmetic, all the fanfare is there, but when the real implementation comes in terms of the scientific approaches and integration of scientific knowledge to bring out the best out of it, that something is not there. I can tell you, with all the certainty, and I know it from the highest level down there. So that's what the problem is.
Well, thank you, sir. And another question that is coming up, that if these high-rise buildings over the cities, in the cities, if they are having any role in falling water level in the cities?
They have. I mean, conjunctively, they do have a huge role. But if you look at individual high rises, they potentially, decrease the water level in a certain locality. Now, in areas like Kolkata, again, there is plenty of water, actually, plenty of groundwater, although much polluted, but still there is plenty of groundwater. But, like the groundwater condition is slowly changing. And when you say the high rises and their impact on them, they would not be visible at the present times because, the high rises are there only for the last 20 years or so. And the volume of water there is in Kolkata, you would not see a direct consequence of that immediately. But if you think about projection, or if you can do very high resolution studies with numerical integration, you would start seeing the impact. They are forming what we call extended cones of depression. And yes, it is eventually affecting it conjunctively.
Sir, as you have already spoken about AI, application of AI in this groundwater, one of the questions has been coming up: how a mathematician can help in the study of arsenic contamination modeling in the groundwater space?
Now mathematics is the basics of most science, right? All of us know that. Right. And when we observe something, we are natural scientists. We are not really a mathematician. Now we observe some phenomena like physical or chemical phenomena. We do understand that there are some basic mathematical principles by which we can explain it. It's not the mathematics that controls the science, but rather you can explain the science by the mathematics. It's the other way around, right? So if you can do that, and if you can find out the causal relationships, the cause and effect relationship, if you can determine the mathematics through it, you can use mathematics, of course, with a word of caution to predict something that can happen in the future. Now, the word of caution is, now people get a bit overwhelmed and they take things too much than what the limit is. Every study, and that's what I tell my students, there are two things that you should be absolutely aware of from the beginning of the study. Number one is the scale of observation. What scale you are observing? Because the micro scale to the macro scale to the cosmic scale don't work in the same way. So you have to very certain on the scale of observation, number one. And number two, do get to know about the boundary or the limits of your techniques or observation.
Right.
Don't overextend what you're observing. So when I say AI can be beneficial, but then that also needs to augment it with field study. The present trend is everybody wants to do AI because that's a buzzword, and they don't understand what's happening on the ground. That cannot happen. You have to integrate the two,
Yes.
simultaneously.
Now I would request Dr. Prantik Banerjee to put up his question. I think he has a question.
Shanti, can I have a question?
Yes, sir. Yes, sir.
Can you hear me?
Of course.
Yeah.
Yes, sir.
Dr. Abhijit is a nice lecture. First of all, thank you very much. But a lot of people are working on arsenic, the areas where arsenic is, heavily contaminated with water. Is there any easy solution to remove arsenic by people,
Yeah, yeah,
particularly in the
yeah.
village?
There are actually thousands of solutions.
You talked about plants and
Yes,
are
yes,
not regularly maintained and things like
yes.
that. But is there any household,
Yeah.
ways that you can remove arsenic
There are
very
plenty
easily
actually.
and very good?
Yeah, there are plenty of, and I would say there are thousands of
But why
solutions.
not people are using this?
There are different reasons.
But why not people are using this?
Yeah, there are different reasons to my understanding. There are social aspect because many times if things are cheap, people don't tend to use it because they think like they don't have the brand value. I know that one of my colleague in IIT Kharagpur, he developed a filter made of laterites. Laterite, the rock that you would get. So it's almost free of cost, right? Um, and yeah, it's almost free of cost, and he developed this technology, and it works very well. I was also a part of that project, so I can vouch you. It works very well. It didn't get picked up either in a commercial scale or a household scale. You know why? The reason was the technology was too cheap. The filter was coming too cheap. Like you can buy the filter in 100 rupees or 500 rupees. So people didn't believe the technology, number one. Number two is because of commercial reasons, the vendors or the agencies also don't tend to promote those filters. They would promote you. I should not, name any brand, but all the fancy filters that you see at your house, none of them actually can stop either arsenic or organic pollutants. None of them. If somebody claims, I can have a real word with that company. None of them. They are only good for, stopping microbial pollution. So, and you know how fancy and how costly they are, right? But if you can tweak them a little bit here and there, you can actually stop the arsenic pollution too. And the third one is like when you have these filters, you would generate sludge or the arsenic concentrate that would come out from the filter. Now, how do you manage it? That also becomes a huge challenge because many of these filters would effectively work for a few days or few months, sorry, and then the cartridge, if I may say, would get spent. How to regenerate that or how do you treat it? So that also something that needs to be understood and needs to be worked out. Other than that, I would say technology-wise, there are 1,000 technologies.
You being an advisor to government of West Bengal, why don't you promote these things and
we do.
government of West Bengal?
We do, but again, like as you and I are scientists, we only understand our niches, right? Now the government, I have worked closely with the government for almost 20 years, working with government of West Bengal.
The government usually listen to IIT people.
They do. They do when they need to. I'll
in
put
many
it that
many
way.
cases they
do.
take the advice of
Absolutely,
IIT
they do.
people. So why
And
don't you?
I have also been an advisor to the Minister of Water Resources, Government of India. But I can tell you from my experience working with both the levels, both the central and the state level, they only listen to us when that suits their purpose. So it's a kind of a pity with science in this country, and I'm sure like you would be much more knowledgeable about the scenario that I'm talking about. I mean, we are all doing science on our own capabilities and whatsoever, but science is still in a backseat in this country. Not about the resource I'm talking about, but it's the attitude, the outcome, because neither the government, neither the industry, or not the common people do understand or try to have a belief on the scientists. It's also our responsibility. We are not keen to translate our knowledge to the common people. We try to keep it a kind of fogged and mythified, right? So that, we are something out of the space kind of thing. So it's also our failure as a scientist to communicate to our science to the other side of the story. And the same way, the other side, the government and the common people and the industry don't trust us. So when you're talking about Atmanirbhar Bharat, it's a great thing. I have asked in so many forums that why can't we even, build a simple pipette in India? The point is, even if a company builds it and comes to sell to me, I possibly would not buy it. I would be the first person to refuse it because I don't have trust in that company or the know-how, the technology. So this mistrust actually has grown too far, and that has actually percolated in all levels. So when you say like, why don't you advise? I do in my own capability, I do, but it's only up to them like how much they listen.
Or you could join hands with the company so that they can sell.
They do
They can
yes,
produce
absolutely.
these filters.
As I said, the companies didn't pick it up. Like, this technology that I'm talking about from my colleague, they didn't pick it up because it was too cheap. That was not, sufficing their commercial need. So, those are harsh reality. Means you would not know them until you get to, observe one of them in first hand. Sorry. But yeah, that's a good suggestion.
And another thing is,
go ahead.
Yeah. Another question is, what about rainwater harvesting?
Yes, rainwater
in cities
harvesting.
as well as in
Yes,
villages.
yes. So rainwater harvesting again is a very optimistic thing to do, and I think if done properly, it can actually make a lot of difference. Some of the problem is that you cannot see one of the problem, and this is what happens. Like when I first presented this work to the government took it very positively. The next thing I see that it has been translated to the highest level of the administration, the highest level, and he is making statements in the TV on the topic in one of his monthly talk show. Of course, never appreciating or acknowledging the background science to it. The next thing I see that the government has already initiated a mission and executing it in a national level. The problem is that this translation happened, and I have no problem, government taking it up in their own way. They never consulted us to understand the nuances. Okay, because see, like, since we are all scientists here, or at least science professionals in some way or other, we understand that what we see as color, like black or white or red or blue, the color would change as soon as we look through a different colored glass. So it is not the color we are observing; we are observing the frequency. As a scientist, we know that. So there are certain nuances which may not be visible to the common people, but as a scientist, we know that. The government were never interested in accepting or including those nuances in their own, decision making. Even not their own people, like the Minister of Water Resources, they have done miraculous amount of work, and I know some of their former chairmen, and they have huge load of data sitting with them. When the government on the other side is administrating or executing some of these projects, they never even thought about looking through those outcomes of this project. So going back to your question on the rainwater harvesting, it is a good cosmetic thing to do. I mean, some places it does work, but if you don't know the dynamics, the fluid dynamics, as well as the subsurface hydrodynamics, it is not going to make much difference. So it has to be a match at both ends. The effort has to be there. Of course, in many instances it is there. And also like how it is augmented to the aquifer system or connected to the aquifer system, that also has to be there. So unless you make that connection, in reality, it possibly would not do much good.
Okay, thank you.
Thank you, sir. And it was an enthralling talk. I mean, so at one end of the spectrum, we find that a positive side, that is groundwater is indeed getting rejuvenated. And at the other end, we find the policymakers, the so-called statesmen of our country, they accept science at their own convenience.
That's always the case. That has always happened over the millennia.
Yes. So, and perhaps we specialize in it.
Well,
Anyway, I have a question that
sure.
Technically, what is the mechanism through which pumping is aggravating this arsenic problem in groundwater?
So what happens is, in the subsurface, if you look at water, groundwater, again, it's kind of difficult for non-specialists to visualize how the groundwater is positioned in the subsurface. But let me just tell you, you can visualize it, and this is not a very right way of saying it. It's a very slow flowing river kind of thing. Okay, of course through the rocks and sediments and so on, but there is a constant flow of the water. So all the laws of fluid dynamics are conserved and so on. Now, so it's basically a laminar flow if you call it in a physics term. But as soon as you introduce a pump and start pumping through it, that laminar flow would be destroyed, and now you have a non-laminar or like turbulent flow. Now, once you have this turbulent flow, it changes the dynamics of the whole region, and it basically changes. If you are from physics background, you would know that the flow paths or the particle flow paths would change. Consequently, what happens in places which otherwise the arsenic would not be moving to, or would be moving at a very slow rate, now because of this turbulence in the groundwater system, would now start moving in a very fast rate. Okay, so to give you the best or the closest example, I would think, if you take a mixie in a kitchen, like a mixer grinder, and if you put some water there and just keep it there, you see like the water is floating and it's barely moving, not moving, and just there, right? And if you put something there, sugar there, it will just sink in or stay somewhere in some location. Now, as soon as you turn on the mixie or um, the mixer grinder, it will go like this, and once you turn it off, everything is mixed, right? And that happens because two things. Number one is the fluid dynamics changes, and number two, as the change happens, the chemical kinetics also changes, right? So when you do the pumping, the same thing happens.
Thank you, sir. And another one, although it's not directly linked to groundwater security of India, that is, how far feasible is this river linking project?
Again, it's an ambitious project, and again, I have met some of those people who actually did the blueprint of it. It is beneficial in some places, but you cannot take it in a face value and put it as a carpet everywhere. In some places, it do have a lot of benefit. It can be used as a water management technique. But then, since I said it's a water management technique and you come and apply it everywhere, that's not going to happen. So you have to take it a case by case. And I think that's true for most of the things. You cannot use it blanketly.
Thank you, sir. So in retrospect, we find that 1.5 hours is indeed too short for this session. I'd now like to ask Dr. Indrani Ghosh for if she has any questions, and thanks you. Indrani.
Hello, am I audible?
Yeah.
I think this interaction will really never end. It will go on. So one last question to you, sir. So as you have shown that groundwater depletion that is happening in South India and west part of India, but it is not much observed for eastern part of India. So is that because of the problems related to policy intervention, or is it something else?
So in Eastern India, actually, there has been no effort for replenishment, to my knowledge, no large-scale effort, and most of the effort is actually on withdrawal. So if you do just a mass balance, it is almost 5 cubic kilometers of groundwater being taken out every year. 5 cubic kilometers, that's a huge volume of groundwater.
Huge volume.
Yeah, and I don't know, even if there is any replenishment effort, that possibly 0.0001% or 1 cubic kilometers. So the total mass balance says Eastern India and Northern India is largely depleting groundwater, with the highest gradient more toward Eastern India, on the contrary to what people understand.
Okay, sir. But sir, once you mentioned that in Kolkata, still the groundwater is a lot of water is available. So is
Mhm.
it contradicting this fact
No,
or?
no, it's not actually, because it also depends on how the aquifer structures are made. So
Okay,
what I'm talking
right.
about, these are mostly what we call unconfined aquifers, where you have a lot of shallow pumps and taking out the water. Whereas in Kolkata, the aquifer structure is a bit different. I'm not saying that Kolkata is not depleting. It is depleting. Certainly, it's depleting, but the rate is different.
Okay.
Okay.
Okay. Thank you, sir.
Okay.
Thank you so much. So let me take this opportunity to the time for vote of thanks. So first of all, on behalf of School of Basic and Applied Sciences at Adamas University, I express my heartfelt thanks to our honorable speaker, Dr. Abhijit Mukherjee. Thank you so much, sir, for your valuable time and this wonderful talk. It was so insightful. I believe my students, all of the students and including faculty members, we have utilized this time very effectively. It was really fascinating and the interactive session said it all. We are thankful to our Honorable Dean Sir, Dr. Jitendra Pandey, for his immense support and encouragement. I'm thankful to Dr. Professor Shonjit Ghosh for his presence. My sincere thanks to faculty members of our school and the faculty members present from other schools. I express my gratitude to Dr. Prantik Banerjee and Dr. Tanmay De, our team member, for their effort they put in to make this event successful. I also thank participants from outside. A huge number of participants we get this time from outside. Thank you so much for your active participation. And special thanks for the students. Without you, it was really, this event could not be so great, so happening. Thank you so much. And lastly, I want to I'm indebted to my university, our university, for providing us this platform for organizing this distinguished lecture. Thank you so much. Thank you again. And I will request our Honorable Dean Sir, Dr. Jitendra Pandey. So, sir, if you can conclude the session. Sir, I hope you are there. Sir, are you there? Uh, sorry, sir has in another meeting. I'm
No,
very
it's
sorry
fine.
for that.
No, no worries.
So thank you so much. On behalf of sir, I will like to convey the message that in
Sure.
future, when that university will open, we will like to have you in the campus, sir, for
Sure. I'd love to.
face-to-face meeting. And you wanted to do that also. We had a conversation before that you wanted
Right,
to
right.
visit our university once.
Absolutely.
We hope we will be able to do that in future.
Yeah,
Thank you
hopefully.
so much, sir.
Very
Thank you
recent
so
future.
much.
Thank you. Thank you.
Thank you
Most
so
welcome.
much.
Thank you.
So with this, I'm on behalf of our school, I'm concluding this session. I'm bringing this call to an end.
Thank you.
Thank you. Thank you.